A gas with CBA1 CBA equal to gamma goes from initial state something to final state something through an adiabatic process. The work done on the gas is, so A option है nRT1 minus T2 upon gas. So adiabatic का मतलब heat zero, मतलब कि work done क्या on the नहीं by the gas. That's just negative delta U, right? Yeah, because right. Of course, so just negative delta U because delta U negative रहेगा, right? उसने work किया. Yeah, so negative delta U यानी कितना? Negative NCV delta T, right? So like CV कितना होता है R upon gamma minus 1. Okay, fine. So that's why yes, A is correct. और इसको मैं NRT1 is like PV1. Okay, cool. P1 V1 whatever. So B also looks correct. Assuming कि ये दोनों state equilibrium states है. ठीक है. ये तो गलत है. ये अजीब है because इसमें ठीक है. So A and B next question. 42. 42 is okay. इस process में PV तो मैं क्या VP दिया है. Okay, this is very weird. The magnitude of work done is, so PV इसको interpret करो whatever. The magnitude of work done is just the area under this, right? So क्या हो रहा है, लाइक हायर प्रेशर पे तुम्हारा एक्सपांशन हो रहा है. ओके वेट अ सेकंड, दैट्स नॉट अ थिंग. वेट, सो इसमें राइट, सो यहाँ से यहाँ तक तुम्हारा जो ये एरिया रहेगा लाइक दैट्स एक्चुअली बिगर, एंड फिर यहाँ पे जो एरिया आएगा दैट्स एक्चुअली नेगेटिव. सो वर्क डन बाय द गैस, राइट? या तो वो पॉजिटिव रहेगा. एनीवे जस्ट इक्वल टू द एरिया ऑफ दिस थिंग. सो वो कितना एरिया है? So V1 V2 दिया है, this is like P1 P2. You can't just use pi r square, that's wrong. Instead तुम्हें एलिप्स का फॉर्मूला यूज करना चाहिए pi AB. So pi times ये चीज का आधा V1 V2 upon 2. Sorry, plus V2 upon 2. Well, नहीं, minus, right? Well, yeah. So V2 minus V1 upon 2, and that times of P2 minus P1 upon 2, right? That's the area. So pi upon 4 times. Yeah, so C looks correct. D सही नहीं है. And what is this thing? Pi P2 minus P1 upon 2. That's not right. Once again, मैंने पहले बोला कि pi r square you can't use because वो यूनिट्स सही नहीं आते उसके. एंड थिंक अबाउट इट, तुमने V के तुमने जो एक्सेस की स्केल है वो तुमने चेंज कर दी तो फिर ये एलिप्स बन जाएगा, राइट? इट्स नॉट अ सर्कल एनीमोर. दैट्स व्हाई एलिप्स का फॉर्मूला यूज करो बिकॉज दैट मेक्स मोर सेंस यूनिट वाइज भी और वैसे भी. ओके नेक्स्ट, मतलब इंटीग्रेशन वाइज वो वही फॉर्मूला आता है. ओके 43. A cyclic process is shown in the PT diagram. Wait, but सिर्फ C करेक्ट है, बाकी कुछ करेक्ट नहीं है. It's kind of weird. Yeah, सिर्फ CT करेक्ट है. Okay, जो भी है. 43. Cyclic process is shown in the PT diagram. So the following shows the same process on a VT diagram. So yeah, PT दिया आपने को VT दिखाना है. So pressure versus right. So PV को डालना T, मतलब यहाँ पे pressure versus temperature, यानी यहाँ पे like okay, this is a constant slope thing. मतलब यहाँ पे volume constant है, right? In A to B volume constant रहेगी. So इसमें है A to B volume constant. It seems like that. A to B तुम्हारा pressure क्या हो रहा है? Increase, और तुम्हारा temperature भी increase हो रहा है, right? So तुम्हारी वॉल्यूम तो कांस्टेंट है ना, अभी अभी आपने वही बोला, बट तुम्हारा टेम्परेचर इंक्रीज हो रहा होगा, दैट्स इंपॉर्टेंट. तो यहाँ पे तुम्हारा टेम्परेचर डिक्रीज हो रहा है, दैट्स नॉट करेक्ट. ए टू बी तुम्हारा टेम्परेचर इंक्रीज होना चाहिए एंड वॉल्यूम शुड बी कांस्टेंट. या सो दिस लुक्स करेक्ट, सी लुक्स करेक्ट टू मी. यस ओके, और इसमें ओके वापस, सो दैट मीन्स लाइक सी इज द ओनली करेक्ट ऑप्शन बिकॉज उसी में ए टू बी में वॉल्यूम कांस्टेंट टेम्परेचर इंक्रीज हो रहा है, राइट? या दैट्स द थिंग. यहाँ पे देखो ना डिक्रीज हो रहा है, यहाँ पे कुछ हो ही नहीं रहा है, यहाँ पे क्या हो रहा है, अजीब हो रहा है कुछ, नहीं डिक्रीज हो रहा है एंड दिस इज नॉट गुड. once again increasing, not what we want. A to B temperature should increase, right? Okay, बाकी चेक करने की जरूरत है नहीं, इसलिए अपन कर लेंगे. सो A to C प्रेशर कांस्टेंट, मतलब कि V वर्सेस T में स्लोप कांस्टेंट रहेगा. सो या यू कैन सी दैट V वर्सेस T में तुम्हारा स्लोप कांस्टेंट एग्जिस्ट लाइन. फिर इसमें क्या हो रहा है, इसमें टेम्परेचर कांस्टेंट है, सो temperature constant in that is portrayed over here. ठीक है ना? Next question 44. Heat is applied to certain homogeneous sample of matter at a uniform rate. Temperature is plotted against time as shown. So the following conclusions can be drawn. So initially क्या था? So इसका temperature कैसे change हो रहा है, right? This is like latent heat तुमने provide की है basically. Specific heat capacity is greater in solid state and in liquid state. Probably ये solid होगा, ये यहाँ पे liquid हो चुका है, and then एक और so like यहाँ पे gas होने वाला है or something. Or it could be like it's liquid. Okay, नहीं, फिर यहाँ पे दो latent कैसे आए? It should be solid over there. So solid पे okay, what is the specific heat? It's like heat upon temperature change. In this case, like time upon temperature, right? Which is opposite of the slope. तो इसका slope बड़ा है, मतलब इसकी heat capacity छोटी होगी from this thing. So liquid की heat capacity बड़ी है than solid. Okay, heat capacity is greater in the liquid state than the solid state because right में ज़्यादा heat लग रही है for same temperature thing, right? So B looks correct. B looks correct. 44, right? और क्या है? It's latent heat of vaporization is okay. Sorry, greater than the latent heat of fusion. So time देखो ना बस that is right. Latent heat of vaporization is greater than the latent of fusion. Yes, I believe that. तो already बड़ा है. तो पता नहीं इससे आगे भी होगा क्या ग्राफ हो सकता है ना? Okay. Yes. So C is also correct. Next question. 45. 45 is two ends of a uniform rod of thermal conductivity K are maintained at different but constant temperatures. The temperature gradient at any point is d theta upon dl equal to the difference in temperature per unit length. The heat flow per unit time per unit cross section of the rod is I. Okay, so heat flow per unit time is like what? Just K A upon L times delta T. So अपने को per unit area भी चाहिए ना? Yeah, per unit cross section. So just K upon L times delta T. Delta T upon L is just d theta upon dl throughout. So it's just K d theta, K d theta upon dl, right? Yeah. Oh, it's like equal to per unit length for sure. So सबके along throughout every cross section हमारा heat flow same है, right? मतलब h upon a value हमारी same है, which means K upon right. So like K dt upon dl, that is the same everywhere. D theta upon dl, whatever. Yeah, that's the same everywhere. That's what I'm saying. So yeah, like d theta upon dl is the same for all points on the rod, I believe. Okay, और क्या? That's what is, yeah. Okay, I will increase. What is I? The heat flow per unit time per unit cross section is I. अच्छा ये जो चीज़ है it's I. Intensity something like that. Yeah, intensity. So intensity is constant everywhere. Uh, yeah, because yeah, that is the thing. So I will decrease as we move from higher to lower temperature. That is wrong. I is same everywhere. I equal to K is that. So C is correct. अपने को चाहिए correct options I think. So A is correct. C is correct. Yeah, so it's A and C. Next question. 46. Wait, that's like assuming कि तुम्हारा oh god. But nahi, we know that I has to be the same everywhere, right? It's like yeah, energy का balance steady state ना steady state I guess equal to the temperature difference in okay per unit length. नहीं यार तो अजीब हो रहा है. Because that would mean कि steady state में है, which is okay assumed, right? Okay, next question. One end of a uniform rod of length 1 meter, so length is 1 meter, placed in boiling water while its other end is placed in melting ice. A point P on the rod. So एक क्या है boiling water and one is melting ice. This is 100 degrees Celsius and this is 0 degrees Celsius. Okay, जो भी है. A point P on the rod is maintained at constant temperature 800. Ooh. Okay, the mass of the steam produced per second is equal to the mass of the ice melted per second. So P यहाँ पे कहीं तो भी है, right? Let's just say this thing is x. This is going to be 1 minus x meters in that case. जो भी है. Okay, the mass of right ठीक है ना, mass of steam produced per second, this is like water, नहीं this is ice, this thing is water, right? Okay, equal to the mass of ice melted per second. If specific heat, if specific latent heat of the steam is 7 times the specific latent heat of ice, so यहाँ पे क्या 7:1 का रेशियो है. ओके कूल. सो इसमें हीट फ्लो 7 टाइम्स लगने वाला है बिकॉज मास हमारा सेम है. यहाँ पे हमारा हीट फ्लो 7 टाइम्स है. दिस P is at 800. So just have 700 upon x is equal to 7 times of यहाँ का heat flow is just what 800 upon 1 minus x. Basically that's what they're saying. इसका मतलब क्या हुआ that this happens 8 यहाँ पे चाहिए basically. Just 1 minus x is equal to 8x. So like x is equal to 1 upon 9. So it's 1 upon 9 meter from this left end. Okay. Distance of P from the steam chamber. This is steam chamber. Yes, I believe that. Yeah, okay, it's just 1 upon 9 meters. So C is the answer. Next question. God, yes, next. Next. 47 is A and B are 2 points on uniform metal ring whose center is C. The angle ACB equal to theta AB are maintained at 2 different constant temperatures when theta equal to 1. Wait, what? Uniform metal ring. अच्छा, so okay, angle ACB. C क्या है? Whose center is C. Okay, so his center C है. This is ACB. Is 180 degree. Okay, fine. वेट नहीं, इसे थीटा बोला है, नॉट 180 डिग्री, ठीक है ना। सो बी यहाँ पर कहीं तो भी रहेगा, दिस इज लाइक दिस एंगल इज थीटा, जो भी है, एंड ये एक वायर पर बेसिकली, ओके, एंड वी आर मेंटेन एट टू डिफरेंट कांस्टेंट टेम्परेचर्स, okay, when theta equal to 180 degree, the rate of total heat flow from A to, wait, जो पूरी रेंज रहेगी वो like ऐसी है ना, yeah, okay, when theta equal to 180 degree, the rate of heat flow from A to B is 1.2 watts. When theta equal to 90 degree, the rate, okay, this rate will be, so जो theta ये है, then right, okay, so let's just say delta T है इसमें absolute gradient जो भी, and then I know formula, I don't know for sure correct है कि नहीं यहाँ पे अप्लाई करना, मतलब just assume कि ये like एक thin wire से कुछ तो भी है, so cross section जो bend हो रहा है उसको तुम ignore करो भी के लिए, right? It's just K A अपन, या फिर इसे proportionality बोल दो, that's gonna work out, so proportional to A वो तो चला जाएगा whatever, just 1 upon L, right? So our, you know, heat flow is proportional to 1 upon L, it seems, and of course delta T बोल देते, but delta T तो same रहेगा दोनों के लिए, so yeah, मतलब ये 1 upon L यानी कि this is like theta is to, sorry, 1 upon theta is to 1 upon 2 pi minus theta, right? That is, yeah, okay, so heat flow is proportional है, so जब theta 180 degree है, it's like this, and then theta is 90 degree, what happens? जब theta 180 है, then you just have, so let's talk about, you know, let's talk about, so पहले theta versus कितना चाहिए अपने को, total heat flow from A to B, and also you just want ये जो वैल्यू रहेगी 1 upon theta plus 1 upon 2 pi minus theta, right? So when theta is what? 180 degree, just pi. This becomes like what? 1 upon pi plus 1 upon pi, which is 2 upon pi. So 2 upon pi पे heat flow कितना है? 1.2 watts. Okay, and then when theta is what, like when 90 degree, right? So just pi upon 2 पे. This is like 2 upon pi plus what? Uh, God, so much 1 upon 2 is like 1.5, 3 upon 2, right? So yeah, just 2 upon 3 pi, which is 8 upon 3 pi. Yes, so जब ये 8 upon 3 pi है, then heat flow क्या रहेगा, ये रेशियो से होने वाला है, राइट? सो ये कितने से तुम्हें मल्टीप्लाई कर दिया, जस्ट 4 upon 3, so it's 4/3 of this guy, which is 0.4 times 4 is like 1.6, so C is the answer. Next question, 48. ये तो मेंस लेवल की हो गया यार अचानक से, फिर शायद से आगे अच्छे क्वेश्चन आने वाले, इसलिए whatever. Let an meter deep lake, the bottom is at constant temperature 4 degrees Celsius, that air temperature is at constant negative 4 degrees Celsius, the thermal conductivity is 3 times that of water. Okay, एक 10 meter lake, okay, so H, let's say D is equal to what, 10 meters, okay, constant temperature 4 degrees Celsius, जब bottom जो है that's like 4 degrees Celsius, air temperature is negative 4 degrees Celsius, भूल जाओ ये सब लिखने का, just do the thing, तो ये 10 है, okay, and the thermal conductivity of ice is 3 times that of water, so that water की K है, that is like, oh god, the bottom of what, the bottom of the lake, okay, air temperature, तो यहाँ पे आइस की भी लेयर होगी, राइट? और 10 मीटर क्या है, 10 मीटर डीप लेक, बट देन ओके उसमें आइस इंक्लूड कर रहे हैं कि नहीं, नेग्लेक्टिंग द एक्सपांशन ऑफ वाटर ऑन फ्रीजिंग, मैक्सिमम थिकनेस ऑफ आइस, आई थिंक इनिशियली तुम्हारा ये था, राइट? ओके, सो एक्चुअली में 10 मीटर फिर इसमें इंक्लूसिव ऑफ बोथ है इन दैट केस, दिस इज लाइक दिस 10 मीटर्स, यहाँ पे आइस भी रहेगी और यहाँ पे वाटर भी रहेगा, सो एक में क्या है के एंड एक में 3K, राइट? So thermal conductivity of ice is 3 times that of water. Relating the expansion of water on freezing, the maximum thickness of ice will be the expansion of water on freezing. So जब ice है constant हो जाएगी, that means like all the freeze नहीं हो सकता, that is the heat flow from water is actually 0, right? Wait, is that a thing? Yeah, so the maximum thickness of ice, that will happen जब और flow नहीं हो रहा है heat. Yeah, when it is not flowing anymore, मतलब कि यहाँ पे कोई temperature gradient ही नहीं होगा in that case, which should mean ये 40 degrees Celsius, but that doesn't actually make any sense. How can that be the case? अगर ऐसे heat ही flow नहीं हो रही है, then wait, what? Okay, the expansion of water on freezing, maximum thickness of ice can be. आई डोंट गेट इट. अगर यहाँ पे ग्रेडियंट रहा देन जस्ट लाइक हीट फ्लोइंग, बट देन सो जहाँ पे भी ये कन्वर्जन हो रहा है वहां पे 0 डिग्री सेल्सियस होने वाला है. ओके, दैट्स समथिंग वी नो. और फिर यहाँ से हीट ऊपर फ्लो हो रही है, बट वी जस्ट अज्यूम कि हीट फ्लो नहीं होनी चाहिए, अदरवाइज बॉटम इज एट 4 डिग्री सेल्सियस. वेट, किसने कहा इक्विलिब्रियम पर है? किसने कहा इक्विलिब्रियम पर है? माइट नॉट इवन बी एट इक्विलिब्रियम, राइट? बट दैट वुड मीन कि यहाँ से हीट फ्लो, ओ गॉड, ये अजीब नहीं हो रहा थोड़ा सा? ओनली थिंग यू आर सेइंग इज कि हीट फ्लो इज द सेम थ्रू आउट दिस क्रॉस सेक्शन, दैट्स ऑल यू आर सेइंग, राइट? या वेट, ये तो अजीब है. अनलेस यहाँ पे ग्रेडियंट ही ना रहा, that doesn't make any sense though. थिंक क्या गलत हो रहा है इसमें? The maximum thickness of ice will be, this is 4 degree Celsius, then this ice will be at 0 degree Celsius जहाँ पे P conversion हो रहा है, because that's when delta G equal to 0. So that's what we'll have to assume. अच्छा, I don't know, ये सही नहीं लग रहा मुझे. This can't happen. It's at constant some temperature, but then oh अच्छा, ये जो okay okay okay, so the thing is कि ये जो 4 degree, right, it's not कि यहाँ से heat flow नहीं होना चाहिए. It's at a constant temperature of 4, right? Earth is warming this layer, last वाली. Okay, that explains it. So right, that's the thing. मतलब कि सिर्फ it's not that bad, I guess. It can be done. The only thing is कि water से तुम्हें ना कुछ हीट मिले, यानी कि यहाँ की जो तुमने यहाँ से जो हीट निकाली फ्रॉम दिस क्रॉस सेक्शन, दैट्स द सेम हीट फ्रॉम दिस क्रॉस सेक्शन एज वेल, राइट? या अगर तुमसे ज्यादा हीट निकालते हो तब वाटर फ्रीज होगा ना. या दैट्स राइट. ओके, सो जस्ट फिगर दिस आउट. तो क्या हो जाएगा? 4 डिग्री सेल्सियस का डिफरेंस है अपॉन दैट टाइम्स ऑफ के, ऑफ कोर्स. सो के अपॉन जो भी लेंथ होगी, लेट्स कॉल दिस एल, राइट? दिस इज इक्वल टू, और ये के कौन है? देन यहाँ पे देगा वंस अगेन 4 डिग्री सेल्सियस का डिफरेंस, देन दैट इज ऑफ 3k upon 10 minus, मतलब 10 minus L is like 3 times of this thing. So ये क्या हो जाएगा? 1/4 of this. So this thing is 2.5. This thing is like 7.5, I guess. Yeah, right. So that's the thing. So maximum thickness will be 7.5 meters. A is the answer. Next question. 49. For a second I thought कि तुम like this was an accelerated system treat कर रहे हो, just तुम air से conductive, right? That would mean कि actual में वो पूरी लेक फ्रीज हो जाएगी. That's not going to happen, right? क्योंकि तुम constant temperature 4 degrees Celsius, that's important. Okay, the spherical black body or radius r, radius power p, rate of cooling is r, right? Like rate of cooling. Oh, okay. Spherical black body hollow नहीं है कहीं भी अंदर से. Okay, just you know area कितना, like r squared, and okay, so P proportional to this thing and R is proportional. Oh, okay, wait a second. P proportional to R squared, yes, and then in that case, capital R is proportional to 1 upon R. So D's answer and B's answer. Temperature का उन्होंने कुछ दिया तो है नहीं, so I don't know क्या assume करना है इसमें. Anyway, 50. Temperature of an isolated black body falls from T1 to T2 in time T. Let C be a constant. Okay. Isolated black body, you mean कि atmosphere को neglect कर डालो? Oh, that would mean just sigma T power 4, like negative dt upon dt is equal to just say k times t power 4 something, right? Where k is some kind of constant, we don't know. Which means कि क्या यहाँ पे t power negative 4 आ जाएगा, just इसको integrate करना है, so negative 3 divide करो, just 1 upon 3 over there, and then t power negative 3 going from something. So from t1 to t2, okay. Yeah, start with, okay, yeah, t1 to t2 in time t, right? और यहाँ पे क्या होगा? Just dt times k, so like kt, sure. अच्छा, c भी a constant, fine. k के जगह I guess इन लोगों ने c assume किया है, जो भी है, तो c times t, right? That makes sense. इसका मतलब क्या हुआ? that अच्छा वो 1/3 k को, okay, 3k को वो c assume कर रहे हैं, then fine, understood. So t like 1 upon 3k को c assume कर रहे हैं. Okay, so t equal to c times, right, अभी cube आना चाहिए ना, so 1 upon t2 cube minus 1 upon t1 cube, that looks correct. So c is the answer. 51. Planet is at average distance t from sun. Its average surface temperature is T. Assume the planet receives energy only from sun and loses energy only through radiations from its surface. Planet average distance t from sun, average surface temperature T. The planet receives energy from the sun only, loses energy only through radiation from surface. Neglect atmospheric effects. If T is bigger than d power negative and the value of n is, what's this thing, d power negative n? Oh, so E is proportional to d power negative n. Okay, so temperature of, wait, अच्छा planet का surface temperature T है, right? So जो sun है, right, उसकी उससे जो power निकल रही है इसके, it's like P. So P upon 4 pi capital, okay, 4 pi d square, that times of pi r square of the planet, right? Yeah, that's the amount of power received by planet. Okay, I guess, yeah. Right. So this is equal to also the amount of power emitted, which is like, I don't know, इसका area कितना होगा, just 4 pi r squared, I guess. Yeah, because yeah, that's got to be a thing. Got it? Yes. It's a black body. Our planet is almost like a black body. So sigma, and then you got T power 4 temperature of the surface of the planet, of course. Right? That's the thing. So इसका मतलब क्या हुआ, that ये तो मर गया somehow, and that basically means like T power 4 is proportional, because P तो उन्होंने कुछ बोला नहीं है इस बारे में. So just have to, yeah, like 1 upon d square, huh? So T is proportional to 1 upon sort of d in that case. Just d power negative 1 upon 2. So n is 1 upon 2. C is the answer. Next question. 52. Two is solar constant for Earth is sigma. Solar constant is defined as energy received per unit area per second normally on Earth. The surface temperature of the sun is Tk. The sun subtends an angle theta at the center. Canada is defined as energy received per unit area per second normally on Earth. Okay. तो क्या वो डिपेंड नहीं करता कि तुम कहाँ पर हो अर्थ की पोजीशन पे, बिकॉज यू वांट नॉर्मल? नहीं, नॉर्मली मीन्स कि तुम्हें नॉर्मल ही रहना पड़ेगा सन रेज से. ओह दैट्स लाइक फाइन, राइट, अंडरस्टूड. इट्स दिस थिंग, वो जो चीज थी अपने पाई आर स्क्वायर अपॉन 4 पाई डी स्क्वायर in terms of power of sun, something like that, right? But yeah, so surface temperature of the sun is T Kelvin. So like radius of sun का कुछ बोला नहीं है इसमें, so just right, like area of sun जो कि right कुछ तो भी होगा, then you want sigma, and then sun का temperature की power 4 right, that's the power emitted. Okay, then this upon 4 pi distance from sun, and क्या बोला, okay, let's do it. So distance from sun का square, then you just have pi r square जहाँ पे, and like it's like r upon 2 upon d, and r upon 2 क्या है, r upon 2 क्या है, wait, you don't want r upon 2 actually, you want 2r, because yeah, that's the thing. So just 2r upon d, that is theta. So मतलब कि r is, okay, so 2r upon d equal to theta, like d equal to 2r upon theta in that case. So यहाँ पे क्या हो जाएगा, like 16, और नीचे थीटा स्क्वायर रहेगा ना, तो ऊपर गया थीटा स्क्वायर, t pi r square घटा, sorry कट गया. I just got this thing, so proportional to theta square and proportional to t power 4. So this is sigma, right? Oh yeah, so t power 4 आएगा इसमें, and इसमें theta square भी आएगा, which means C and A. Next question. Next 53. ये easy वाले क्यों दे रहे हैं अब, I don't know. Rate is represented by this equation where x is in meters, t is in seconds. The wave experiences, sorry, the wave represents, okay, this is written as equation y equal to a sine of 10 pi x plus 15 pi t plus pi upon 3. Okay, jo gaya. So wave traveling in the negative x direction, because it was okay, extension velocity of 4.5, velocity can only just like k and whatnot. Can I x minus ct, right? So you have to divide by this thing, just 10 pi upon 15 pi, no, 15 pi upon 10 pi, sorry. So that's going to be what, 1.5, so 1.5 meter per second, yes. So x meters by t seconds, yes, 1.5 meter per second. So velocity of this thing in negative x direction, So right, B is the correct answer. Next question. 54. Yeah, sort of thing. Next question. A wave is represented by this equation. The frequency is n, wavelength is lambda. So I have 3, 1, 4, जो भी है. Like 100 pi बोल दो इसको approximately जो भी है. So a sin 100 pi, तो pi तो यहाँ पर है, मैं 100 को अंदर ले जाता हूँ. It's like, और ये क्या है 0.5, it's like 2t in that case, right? So it's 200t, okay, minus, so नीचे 100 आएगा, वो cancel हो गया, just x, right, upon meters, yeah, p upon second आएगा, x upon meter. That's the thing, I guess. Okay, it's like a sine 2 pi, and then you just have this thing 100 t per second, and then minus 1 upon 2x per meter. So like 1 upon 2 is a wavelength, and this thing is a frequency. So frequency is n, it's just 100 hertz, and then the wavelength is lambda, it's 0.5 meters. So wait, acha nahi, this is a wavelength upon 2 mein na, so like x upon lambda, that's why this is the wavelength 2 meters. Fine, so C is correct and D is correct. 55. ये easy क्यों लग रहा है मुझे? Plane progressive wave of frequency 25 hertz. Okay, frequency 25 hertz. Amplitude given as this thing 25 times 10 power negative 6 जो भी है. Initial phase 0 moves along the x-axis with the velocity of, so velocity में क्या दी है 300 meter per second. Right. Along the negative x direction जो भी है. Okay, A and B are 2.6 meter apart from on the line of propagation of the wave. At any instant, the phase difference between A and B is phi. The maximum difference in the displacement at A and B is delta. Instant the phase difference. Okay, the maximum difference in the displacement at A and B is delta. Okay. So what is phi? First of all, phi. क्या तुम्हें कितनी distance क्या दिया है A और B के बीच में 6 meter apart? That's easy. I mean, just, yeah. So figure out the wavelength. Wavelength is like what? C upon F. So 6 upon, like, okay, D. D upon C upon F. Like DF upon C, basically, right? That's the thing. And then it's 2 pi. So this is our phi in that case, which is what? So 2 pi times D kitna hai apna? 6, that times of F, which is 25 upon C, which is 25 times 10 power negative. Shit, that's not 25. It's this thing, 300. तो ये क्या हो जाएगा, like इसमें 12 हो जाएगा in that case, which is yeah, you get to think pi. So phi is pi, तो A is correct, and delta कितना चाहिए अपने को? The maximum difference in displacement at A and B. Sine function है ना? Wait, you want the displacement का maximum difference? Well, that can't be 0. That's just not correct. Delta equal to 5 times 10 power. Wait, what if it is in fact just 2 pi? Gotta be careful about this thing. Is phi short? C is kind of 300. 6 meter apart on the equation, right? Just this thing. So 2 pi times D times F upon C. C is this thing. So you can take a 4 times of 3 is 12. ऊपर 12 आ रहा है. So just pi. Phi is pi basically. Yeah, that's got to be the thing. One lambda. Lambda is C upon F for sure. Right, right. और क्या हो सकता है? So phi is pi. So A is correct and delta is, so maximum अपने को difference चाहिए. It's like pi plus something, right? तो एक को pi upon 2 कर दो तो इसका 3 pi upon 2 आ जाएगा, which means कि right. So 2 times amplitude, which is like 50 times, okay, 5 times 10 power negative 5 meters. So D is correct and A is correct. Let's go to 56. Sound wave passes from medium A to B. The velocity of sound in B is greater than in A. Assume that there is no absorption or reflection at the boundary as the wave moves across the boundary. Okay, velocity of B is greater than in A. Frequency change हुई नहीं. Frequency will not change. So A is correct. The wavelength will increase. I mean, velocity में bigger चाहिए. So of course that has to happen because otherwise कैसे होने वाला है? The wavelength will, okay, no. Okay, the intensity of sound will not change. It will change. Reflection होना चाहिए. Oh wait, क्या बोला? Assume that there is no absorption. Okay, that explains it. the intensity of sound will not change. Energy conservation के according there should be the same intensity in that case because reflection or absorption नहीं है. So then it's the same intensity it seems, right? Or not? Uh, I guess intensity will not change. So D looks correct. Okay, cool. थोड़ा सा अजीब नहीं है ये. So for light, it might be complicated, but what about like for sound or something? So अगर plane wave है of sound, right? So this is very weird. Okay, वो भी छोड़ दो. एक हम string waves की बात करो. तो string waves की बात करते then yeah. So suppose right, then intensity will not change. But string waves में intensity का कोई concept ही नहीं है ना. It's just power. There is no such thing as intensity. So फिर you have to take the case of sound, but then for sound तुम्हें plane wave अगर generate कर दी, it's like तुम्हें दो boxes, you will need containers for this thing अगर plane wave generate कर दी, and then this is getting complicated, isn't it? अपने को पता है that what happens is that reflection होता है and because of that intensity does change, but then ये unnatural phenomena अपन कैसे? Okay, then intensity will not change it seems. Okay, 57. No, it will look. Energy change नहीं होगी, I get it, but then the time required for it does change, right? So intensity does change in fact. So like you can think of it like photons. Okay, थोड़ा अजीब हो रहा है, it's not making sense. Uh, yeah, because तुम्हारी but नहीं तुम्हारी frequency change हुई नहीं, so hits per second is the same and per hit तुम्हारी same energy है, then this should not be changing at all. God, ये अजीब हो रहा है, it's not making sense. अगर तुम्हारी वेवलेंथ चेंज हुई then like बट तुम्हारी फ्रीक्वेंसी तो चेंज हुई नहीं, सो इवन तो तुम्हारी स्पीड बढ़ गई बट क्योंकि तुम्हारी डेंसिटी उतनी नहीं है अब, तो इंटेंसिटी स्टिल इज नॉट चेंज एक्चुअली. So D is in fact correct. 57. Transverse sinusoidal wave of amplitude A, wavelength lambda and frequency f is traveling on a stretched string. Maximum speed at any point is v upon 10, where v is the speed of propagation of the wave if a equal to 10 power negative 3 and b equal to amplitude lambda, wavelength lambda, sorry, amplitude A, wavelength lambda, frequency f, traveling on stretched string. Maximum speed at any point on the string is v upon 10. Where v is the speed of propagation of. Okay, cool. Okay, cool. So basically क्या बोलो, like a omega is equal to v upon 10. And what's omega by the way? That actually depends, right? Okay, v upon 10. Right. Where v is the speed of propagation of the wave. Oh, you can use this fact that v will just be in that case be equal to what? Omega upon lambda, right? So omega upon k और जो भी है, or something like that. So basically तुम क्या बोल रहे हो? A times 2 pi frequency is equal to frequency times wavelength upon क्या था ये upon 10, right? So the wavelength is just 20 A, right? Well, yeah, it's 20 A. Okay, so wavelength तो अपन निकाल चुके हैं in that case. It's just 2 times of 10 power negative 2. Shit, नहीं 2 pi. Okay, pi है ना यार, मैं भूल कैसे रहा हूँ उसको. So f cancel हो जाएगा. Just get this thing. Wavelength is equal to 20 pi A. So ये क्या चाहिए? Just 2 pi times 10 power negative 2. So A is correct in that case. और अपने को चाहिए so देखो wavelength मिल चुकी है. Then just want what? The frequency. The frequency is what? ये v upon lambda, right? Which is 10 power 3 upon 2 pi. So yeah, C is also correct. Next question. 58. नहीं, ये JEE एडवांस लेवल की नहीं है. Something's just going wrong. But मॉड्यूल का नाम तो JEE एडवांस दिया है. So ये कैसे हो रहा है? When an open organ pipe resonates in its fundamental mode, then at the center of pipe, the gas molecules undergo vibrations of maximum amplitude. Open organ pipe, okay. Fundamental mode में, okay, open organ pipe, right? दोनों साइड से, I guess. Yeah. Then वहाँ पे displacement के nodes नहीं, anti nodes रहने वाले, right? Okay, cool. इसमें anti nodes रहने वाले, and it's in the fundamental frequency as well. Okay, so it's like this. So yeah, ये जो open, yeah, बीच में एकदम में नोड मिलेगा एक, यहाँ पे एंटी नोड है, यहाँ पे एंटी नोड है फॉर डिस्प्लेसमेंट. So हाँ, the gas molecules undergo vibrations of maximum amplitude. Okay, at the center of pipe, no. The gas molecules are at rest. Yes. The pressure of gas is constant. No, it's changing at the maximum amplitude. So B is right and D is right. 59. Okay, a whistle emitting sound of frequency something approaches a stationary observer at speed of 33 meter per second. Velocity of sound is 330 meter per second. Frequency heard by the observer in hertz is what? Seriously, कैसे घटिया क्वेश्चन है? Just okay. Whistle emitting sound of frequency तुम्हें दी हुई है. Approaches a stationary observer at speed 33 meter per second. Okay, velocity of sound is 330 meter per second. क्या? The frequency heard by the observer. So it's like क्या formula होता है? C minus V observer upon C minus V source, right? Yeah, okay. That times frequency emitted by the source. So frequency to दी 450 hertz. Observer is what? Stationary, so just upon 1 minus C upon V. So V source कितना है? Just C upon C minus V कटा लो. C is 330 upon 330 minus what is V source? It's just 33. Come on, what do better than this thing? 450 upon 1 minus of 0.1, it seems. It's like around 0.9 in that case, which is 500. So 500 hertz, which is D. Next question. Yeah, frequency heard by the observer in hertz. Next question. 60. Approaching है ना, not retarding. So yeah. Yeah, okay, next question. 60. Bus is moving with velocity of something towards the huge wall. Driver sounds a horn of frequency 165 hertz. The speed of sound in air is 335 meter per second. The number of beats heard per second by the passenger on the bus will be. Okay, cool. Velocity में दी हुई है towards a huge wall. Driver sounds a horn of frequency. Okay. The speed of the sound in air is 335. Okay. Number of beats heard by the passenger on the bus. Ah, right. Okay, understood. So एक तो वो खुद ही frequency रहेगी because 165. Right. Wait. तुम्हारा यहाँ पे पैसेंजर है, यहाँ पे तुम्हारा हॉर्न है. So sound is like going in this direction. ये ऐसा मूव करे, moving in this direction. या मतलब वो coordinate wise वो हो ही जाएगा in the end, right? So with respect to yeah, that is the thing. So ठीक है ना, बस में तो वो सेम फ्रीक्वेंसी रहेगी 165 हर्ट्ज बिकॉज वो C minus V कैंसिल हो गया. We don't like C is in fact negative that case. So wait, या दोनों नेगेटिव है नॉट ओके अंडरस्टूड. और दूसरा रहेगा कि यू एमिटेड दिस थिंग. तुमने जब ऐसा किया तो तुमने इनफैक्ट इसकी वेवलेंथ चेंज कर दी ना एमिट करते समय. फ्रीक्वेंसी तो तुमने स्टिल सेम रखी है. तो या वेट, डैम, राइट, तुमने इसकी वेवलेंथ चेंज कर दी पर तुमने फ्रीक्वेंसी सेम रखी है. तो वेवलेंथ का इफेक्ट भी कैरी ऑन होगा ना, राइट? थिंक अबाउट इट. यहाँ पे जो ऑब्जर्वर रहेगा लाइक अकॉर्डिंग टू हिम फ्रीक्वेंसी चेंज हो जाएगी. देन वो तुम राइट, आई गॉट इट. सो तुम जब इसको वापस डालोगे तब फ्रीक्वेंसी चेंज हो चुकी रहेगी बिकॉज ये तो स्टेशनरी है. दैट्स वाई वो इफेक्ट कैरी ऑन हो जाएगा. राइट, कूल. तो ये क्या रहेगा, जस्ट पहले क्या रहेगा सी अपॉन, तो फ्रीक्वेंसी कैसे चेंज होगी, सी अपॉन क्या होता है माइनस वी सोर्स. इस केस में वी सोर्स इज पॉजिटिव लाइक माइनस वी इज वेलोसिटी ऑफ बस जो भी है. Okay, that is the frequency. This is the frequency. That is the frequency heard by this wall. वो उसी को वापस emit करेगी. And then this times अब V source is like 0. V observer क्या है? It's negative in this case. Like okay, C plus V observer, which is V in this case, upon C. So this is the answer. मतलब कि F times of C plus V upon C minus V. That's the other frequency. So इसका subtraction करना है. This minus of F. That's our beat frequency, right? So कितना हो जाएगा, just 2V upon C minus V. तो कितना है वो V कितना दिया हम लोगों ने? अच्छा 165 हर्ट्ज टाइम्स what is V? 10. Okay, यहाँ पे 10 आ जाएगा upon 335 minus 330 in that case. So just upon 33. 5 times of this thing, yes. So just 5 hertz. C is the answer. Beat frequency. Yeah. Next question. 61. Railway engine whistling at constant frequency moves with the constant speed intergoes past. It goes past a stationary observer standing beside the railway track. The frequency N of the sound heard by the observer is plotted against time. So the following best represents the resulting curve. Okay, right. से कम चेंज हो रहा होगा जब वो ठीक ऑब्जर्वर के सामने है उसका इंजन, राइट, एट दैट पॉइंट, बिकॉज अपन ने पहले भी किया हुआ है ना ये. यस. सो राइट, आई थिंक सी इज करेक्ट, क्योंकि ये सारे डिस्कटिंग ये तो घटिया है, बिकॉज दिस मेक एनी सेंस. सी प्रोबेबली इज द वे टू गो. यहाँ पे डिसकंटिन्यूटी अजीब टाइप की विच डजंट मेक एनी सेंस, बिकॉज अपन ने जब किया था वी गॉट दैट इट्स नॉट चेंजिंग अ लॉट जब वो लाइक इट पासेस थ्रू द ऑब्जर्वर, राइट. Yeah. Okay, this is not making any sense as well. So I think C is the answer, right? Yeah. 62. I mean, it does depend on D. So, this starting side track. I'm starting to think कि शायद से D correct है, because as much as I remember ये actual में correct graph है नहीं. Yeah, so probably, just probably D is correct. Although इसमें अजीब है कि तुमने discontinuity की है, it should be like तुम उसको थोड़ा सा smooth कर दो and then it's the correct graph, right? So probably D is correct. Next question. 62. Assume that the sun rotates about an axis through its center and perpendicular to the plane of rotation of the earth about the sun. The appearance, because अपने को पता है एक्चुअली ग्राफ कैसा होना चाहिए. The graph should be like this, right? So यहाँ पे ऐसे एक steep downhill है, right? That should be the thing, I guess. Anyway, 62. Assume that the sun rotates about axis through its center and perpendicular to the plane of rotation of earth around the sun. So it rotates about an axis through its center. Sun, okay, rotates to the center. Perpendicular to the plane of rotation of the earth around the sun. Okay, the appearance of the sun from any point on the earth is shown. Light belonging to a particular spectral line as received from the points A, B, C, D on the edge of the sun are. Oh right, यहाँ पे relativistic Doppler effect, right? Well, I don't know the formula for that. मुझे याद नहीं है basically, right? So I'm not going to do this thing. अगर मैं नॉर्मल डॉपलर इफेक्ट करने का ट्राई करता हूँ देन प्रॉब्लम मेरा गलत हो जाएगा, बिकॉज 62 में इसको बस छोड़ रहा हूँ के लिए. आई विल हैव टू सर्च दैट फॉर्मूला वंस अगेन, बिकॉज इट्स रिलेटिविस्टिक. इट्स नॉट लाइक नॉर्मल प्रोपोगेशन जैसे होता है ना साउंड वेव्स का, वैसा नहीं है ये. सो यू कैन जस्ट यूज दैट फॉर्मूला फॉर लाइट. ओके, 63. बस सोचे देखो ना यार, स्पीड जो रहेगी लाइट की सेम रहेगी सब ऑब्जर्वर्स के लिए, व्हाट नॉट, एंड बहुत कॉम्प्लिकेशन हो रहा है. सो फाइन, जस्ट मूव ऑन. 4 identical charges are placed on points. Okay, the potential at the origin is 0. Identical charges बोल रहे हो, so potential at the origin. No, it's not 0 because this distance is, well, okay, सारे same charges है, so it can't be 0. Field at origin is 0. So एक है 1,0 के full. So यहाँ पे -1,0 भी है. Okay, then it's like वो field cancel हो गए, फिर यहाँ पे similarly वो fields cancel हो गए. So field at origin is 0. Potential at all points on the z-axis other than origin 0. No, ऐसा नहीं रहता है. The field at all points on the z-axis other than origin acts along the z-axis. Z-axis, इसमें x y को use किया ना. Okay, cool. Right, it's that kind of configuration of it. तो मैं z-axis. Right, the field does act on the z-axis. And then at origin it's 0, so थोड़ा सा अजीब है. So yeah, D looks correct and B looks correct. 64. 64 is 4 charges all of the same magnitude are placed at the 4 corners of a square. At the center of the square, the potential is E and the field is E. A suitable choice of signs of the 4 charges which is following can be obtained. 4 charges, same magnitude, placed at the 4 corners of a square. Okay. At the center of the square, potential is V and the field is E. So इस वाले जैसा ही हो रहा है ना. Okay. By suitable choices of the signs of the 4 charges which are the following can be obtained. So field तो 0 रहेगी at all times because center of charge, right? Potential is not zero because wait नहीं, all same magnitudes. Oh, that means कि अपन फील्ड को नॉन जीरो भी कर सकते हैं at some point. सेम मैग्नीट्यूड बोला, ऐसे कहीं बोला नहीं कि वो सेम चार्जेस हैं. सो ये ऐसा होगा, बस में चार चार्जेस है. यू कैन मेक दिस पॉजिटिव, दिस हैज नेगेटिव, दिस हैज पॉजिटिव, दिस हैज पॉजिटिव. तो फिर तुम्हारी फील्ड विल पॉइंट इन दिस डायरेक्शन, राइट? शिट, देन उल्टा कर रहा हूं मैं, इन दिस डायरेक्शन, राइट? या, so it can be done. Field can be made non-zero. So field is not equal to zero. Yes, that's obtainable. Potential equal to zero. That's also obtainable. तुम यहाँ पे इसको सेम नेगेटिव चार्ज पर डालो, राइट? Then boom, यहाँ पे field still non-zero है, but potential is zero. Potential equal to zero and field equal to zero. I doubt that, but then it can be, right? It can be done. अगर तुम इसको ऐसा करो तो. Look at this. Yeah, there is no field, zero, and potential is also zero. Yeah, so A is obtainable, B is obtainable, and potential is not equal to zero, field equal to zero. Of course, obtainable. Look at this. So yes, C is also obtainable, and potential is not equal to zero, field is also not equal to zero. वो तो अपन ने देखा ही ना. It is obtainable as well. कि तुम A को नेगेटिव कर दो, then potential is not zero anymore, and field is also not zero anymore. So सारे obtainable है. So A, B, C, D. Next 65. Deuteron and alpha particle are placed in electric field. The force acting on them are F1 and F2, and their accelerations are A1, A2 respectively. Electric field में deuteron and alpha particle. Okay, so okay, deuteron, alpha particle. Charges कैसे रहते हैं? Deuteron is just like क्या proton जैसा रहता है, charge 1, जैसे E whatever, and alpha particle में 2E. masses कैसे रहते हैं इसके? न्यूट्रॉन में 2m रहेगा, इसमें 4m रहेगा, whatever. जब E और m ऑफ कोर्स इलेक्ट्रॉन के मास चार्ज है, उल्टा होना चाहिए, whatever. तो अपने करना क्या है? देयर एक्सेलरेशंस. ओके, फोर्सेस एक्टिंग ऑन देम आर F1, F2. उनका रेशियो कैसा रहने वाला है? सॉरी, F1, F2. राइट, सो रिस्पेक्टिवली आई गेस. ओके, कूल. तो इसमें 1:2 रहेगा बिकॉज फील्ड, एंड देयर एक्सेलरेशंस आर 1/2:1/2. Oh god, just 1:1 in that case. Well, okay, this is weird. E upon m ratio same है इनका, ठीक है ना फिर? Right. So acceleration A1 equal to A2. Yes, F1 is not equal to F2. So B is correct and C is correct. 66. Honestly, J-mean type का हो रहा है ये. इतने easy क्यों है ये questions? Let V and E be the potential and field respectively at point which the following assertions are correct. V and E potentials and field at certain point. Okay, if V equal to 0, E must be 0. No, that's just stupid. अपन यहाँ पे देखा कि V is equal to 0 is not equal to 0. अपन एक देख चुके हैं. E not equal to 0, V cannot be 0. क्या? नहीं हो सकती है. If V is not equal to 0, E cannot be 0. What? तो तुम ऐसे बोलोगे अगर E को 0 होना है then V has to be 0? No. So none of these are correct. These is the answer. 67. Like V not equal to 0, E still can be 0, right? Okay. In a uniform electric field, all points are at the same potential. That's stupid. That's not the case. Potential का कोई meaning नहीं रहा in uniform electric field. Okay, 2 points can have, unless तुम्हारा potential at some point define कर चुके हो, then that's okay. No 2 points can have the same potential. That's also wrong because तुम field से perpendicular जाओ, right? Pairs of points separated by the same distance must have the same difference in potential. That's also stupid. तुम एक perpendicular जाओ, एक along जाओ, that's not the same. So none of these. ये कैसे questions है यार? 68. Spherical conductor A lies inside a hollow spherical conductor B. Charge Q1, Q2 given charge A and B. Okay. Hollow spherical conductor B. समझा. So charge Q1, Q2 given to A and B respectively. ठीक है ना? No big deal. So A को तुमने दिया है Q1 and B को तुमने दिया है Q2, right? तो Q2 बाहर आ जाएगा, इसलिए Q2 प्लस Q1 तक बाहर आ जाएगा, and then नेगेटिव Q1 यहाँ पे आएगा, right? Because इसके अंदर जो रहेगा, इस लेयर के अंदर it should be zero field, and इसके अंदर तो already zero field है. So charge Q1 will appear on the outer surface of A. Yes. Charge negative Q1 will appear on the inner surface of B. Yes. Charge Q1 plus Q2 will be on the outer surface of B. So A, B, and D. ऑनेस्टली ये नहीं है एडवांस लेवल, ये क्यों मुझे ऐसे क्वेश्चंस दे रहे हो? 69. Parallel plate capacitor charged from a cell and then isolated from it. The separation between the plates is now increased. The parallel plate capacitor is charged from a cell and then isolated from it. Okay, separation between the plates is now increased. The force of attraction between the plates will decrease. तुम्हारे चार्जेस स्टिल सेम है, तुम्हारी चार्ज डेंसिटी सेम है, एरियल डेंसिटी ऑफ कोर्स. सो तुम्हारी फील्ड सेम रहेगी फॉर बोथ ऑफ दिस. द फील्ड इज नॉट चेंजिंग, तो फोर्स भी चेंज नहीं होगा. द फील्ड इन द रीजन बिटवीन द प्लेट्स विल नॉट चेंज. यस. ओके. The energy stored in the capacitor will increase. Yes, because तुमने energy input करी to separate them. The potential difference between the plates will decrease. Decrease? Wait. Oh yeah, like from that to that. Wait, no. You mean the magnitude, right? No, that won't decrease, it actually increases. So कौन से correct है? सिर्फ C and B as well. So B and C. Next, 70. When a charge of amount Q is given to an isolated plate X of surface area A, its surface charge density becomes sigma 1. When isolated identical plate Y is brought close to X, the surface charge density of X becomes sigma 2. When Y is Earth, the surface charge density becomes sigma 3. Huh? Wait, what? Okay, so right, sigma 1 is like what? Q upon 2A. So B is correct. Okay, so A to correct है नहीं that case. That's its surface charge density. Right? Yeah. I mean, this is kind of weird because हमारे पास दो surfaces है. So how do you even तुम्हें एक surface की charge density बोलनी चाहिए शायद से. So the charge density of one of the surfaces, right? I guess so. An isolated identical plate Y is brought close to X. The surface charge density becomes okay. Identical plate. Okay, cool. इसमें भी charge Q है, right? Oh, okay. So this is like Q in that case, and okay, this has to be in this way. Q यहाँ पे, Q यहाँ पे, and यहाँ पे 0, यहाँ पे 0. अब तुम मुझे बताओ, what do you mean by the surface charge density? तुम ये surface की बोलोगे कि ये surface की बोलोगे, या फिर तुम पूरा as a whole thing तुम एक surface consider कर रहे हो? That doesn't actually make any sense. Yeah. So like, what do you want? What do you want? कौन से surface की? Surface charge density on X becomes sigma. I think तुम Q upon A बोलना चाहते हो. Whatever. So sigma 2 is just Q upon A. Okay, which is not sigma 1 for sure. When Y is Earth, तो इसमें तुम चार्ज हटा दे रहे हो प्लीज. No, you are not Earth. Right, तो इसमें तुम अलग चार्ज डाल रहे हो. Oh, yeah, this is negative capacity in that case. तो यहाँ पे negative Q आ जाएगा. Right, of course. It's like this thing कि यहाँ पे Q आएगा and यहाँ पे negative Q आ जाएगा. When you are going to Earth this will happen. because इसका तुम चार्ज चेंज नहीं कर सकते. Then you must counter its field ताकि तुम on these points तुम कुछ field generate ना करो, because Earth क्या बना है अभी. So this potential must be the same thing as this potential, or like any potential over here, right? Yeah. Except ये चीज, क्योंकि ये थोड़ा सा अजीब नहीं है. इमेजिन तुमने अर्थ यहाँ से किया होता, देन तुम्हें यहाँ की फील्ड जीरो करनी पड़ती, राइट? तो वो थोड़ा अजीब नहीं है, बिकॉज इट मैटर्स तुमने कौन सी सरफेस से कनेक्ट किया है. एनीवे, दिस इज द थिंग, आई गेस, राइट? Why is Earth surface charge becomes sigma 3 once again as Q upon A. So sigma 3 equal to sigma 2. Okay, so D is correct and A is correct. Sorry, A नहीं, B, because मैंने अभी click किया. So B and D. Okay, this is it. I'll see you guys next video. ये बहुत ही अजीब था because 30 questions यार, seriously. मैं स्टार्ट में स्ट्रगल कर रहा था सिर्फ 10 क्वेश्चंस कंप्लीट करने के लिए, एंड देन समहाउ ये 30 क्वेश्चंस हो रहे हैं. इजी हो गए ना ये क्वेश्चंस, बहुत ही ज्यादा इजी कर दी इन लोगों ने. डजंट मेक सेंस. व्हाई इज दिस एडवांस लेवल? नो, इट्स नॉट एडवांस लेवल. पर इन लोगों ने नाम तो वही दिया है, दैट इज फाइनल लैब एडवांस. तो ठीक है, जो भी है, यहाँ प्रैक्टिस हो गई. व्हाट नेक्स्ट क्वेश्चन, नेक्स्ट क्वेश्चन. दैट्स इट. आई विल सी यू गाइस नेक्स्ट वीडियो. शिट, ये ऑफ कर. ओह गॉड. एक मिनट, आई गेस आई विल हैव टू क्लोज दिस। हाँ राइट, यहाँ पर है। ओके, सो बाय।